In this video, I'm going to show you how to use timer 0 as an 8-bit timer, maybe as an 8-bit counter also, but I will also show you how this is done in normal mode and how we would start the timer from running, how we can stop it from running, etc. So I will discuss this timer as an 8-bit timer and then also the registers associated with this timer. Now in normal mode, your timer can start at 0 as in this specific case, and with each and every clock pulse that it receives, it will increment, and at some point, and as I've said, this is 8-bit, at some point this thing will roll over, and when it reaches the count of FF, and then it will reset again and go back to 0. So at this rollover, as soon as this thing rolls over, this TOV flag, as you can see here, this flag will go high. This flag sits in the TIFR0 register, which is the timer counter interrupt flag register. And it's actually sitting in bit number 0 also. But this is the flag that will jump up, indicating that there was a rollover. As you can see in this sketch here, in this specific case, the count starts at 0, go to 1, go to 2, whatever, up to FE, then FF, and when it rolls over, the TOV0 flag will become high, indicating that this thing has rolled over. Now we've seen before with the 8051 that yes, you can start at 0, but you can also start at some other point. And you will see that normally in normal mode, we will rather start somewhere else and not start at 0. In the next slides, I will explain that in more detail. So let's have a look at what should be done to program timer 0 in normal mode. The first thing you have to do, of course, is to load the TCNT0 with a start value. And as I've said, that start value can be either 0 or some other value, and the norm is to have it some other value. The next thing you have to do is you have to load this TCC R0A and 0B registers. And as I've said before, this is the control registers, and this is where you will program this specific timer in normal mode, and also where you select the prescaler. Now I'll discuss the prescaler in a little bit more detail, but basically what a prescaler is doing is it will divide the amount of pulses that you supply to your timer. You are used to, in the 8051, or let's say in that specific case, 12 pulses was basically 12 pulses from the crystal oscillator was 1 pulse to the timer. Now in this specific microcontroller, each and every pulse from your crystal will actually increment the value sitting in TCNT0. In other words, the counter register. So if there are 2 pulses, your timer will increment by 2. 5 pulses, it will increment by 5. But what the prescaler is actually doing is it can divide that. So you can have, for instance, a prescaler of 8, meaning it will take 8 pulses and only then you'll get 1 increment in your counter register. Or let's have a look. There's a 64, a 256, and a 1024. So if you put your prescaler on 1024, there will be 1024 pulses and only 1 increment after 1024 pulses. So that is what the prescaler is doing. And you can select which prescaler you want. You can actually select no prescaling, or the clock divided by 8, or divided by 64, or divided by 256, or divided by 1024. But yes, I will show that a little bit later now. You can also select your clock source, meaning if you select the clock source as the internal clock or the crystal from your crystal, then your timer will automatically start. It's not like in the 8051, you had a specific bit which you had to say timer must run or whatever. In this case, you just select the clock source. Once you've selected that, it will start. Then you should monitor the overflow flag. And as I've said, this overflow flag was sitting in that TIF register. Let me just make sure, TIFR0, which is the interrupt flag register, and that's also sitting in bit number 0 of that TIFR0 register. It's bit number 0. And in this specific case, it says here you must monitor this flag to roll over. Well, if you make use of interrupts, which we will get to at some point, you don't have to look at this flag. It will automatically take you to the interrupt handler. So, but in normal mode, without interrupts, which we will look at this flag, once you see this thing is rolling over, you have to disconnect from your clock source, and what we will do is get to this control register, the B1, and just load zeros in there. And again, I will discuss that a little bit later. So this is how you deselect or disconnect the clock source, and then you have to clear the time TOV0 flag. Now this is a strange one. If we say we want to clear something, that means we want to make it 0. In other words, if it rolls over, we've seen already that this TOV flag goes high. But if you want to clear it, you must actually do something strange. If you want to make it 0, what you have to do is you must place a 1 in that flag position. As we know by now, if I put 1 and shift left, and a 0, that means this is a constant value. In position number 0, there's a 1. And if I OR that with a TIFR0 flag, I will basically place a 1, or I'll move a 1 into the TOV0 position. But by moving a 1 into that position, I'm actually clearing the flag. It's strange, but this is the way to clear a flag. You write a 1 to it, and that will clear the flag, meaning it will then eventually force it to become a 0. And this is how you do normal mode programming in timer 0. But we'll do some examples to give you a better idea of what's going on. Okay, let's specifically look at some of the control registers, what they would be doing. If we look at the control register B, for instance, which is this register sitting here, there we can see we've got the clock selector. In other words, where does the clock come from? So if I can just start at the bottom, you can see then the clock source is coming from the T0 pin, which is an external pin. And in this specific device, you can actually decide if you want to have the clock on the falling edge or the rising edge. But this 2, in other words, at the bottom, that is used for counter applications. So if you want to make use of timer applications, it will be basically this. I'm not sure what this color is, but from 001 up to 010. So that will be a normal timer. So just looking at if there's no clock source selected, in other words, if these bits 0, 1, and 2 in the B register are zeros, there will be no clock, and it will also be stopped. If you remember on the previous slide, I've said that you can basically, by loading the B register with all zeros, you will stop this specific device. Then you could also apply a clock with no prescaling. Then you apply 001, and basically then 1 clock pulse from your crystal will give 1 increment on your device, your timer, in other words. Or you can have a prescaler of 8, meaning 8 pulses from your crystal will produce 1 increment on your timer. Or this one, 64 pulses will represent 1 increment on your timer, in this case 256, and in this case 1024. So yes, you can also select this prescaler, and that's sometimes a very nice feature that can be used. So this is how you select your clock selector. So if I want to program no prescaling and there should be a clock pulse and this thing should start, I I could use any one of these values here, but if I want no prescaling, it will of course be 001. But any of these selections here in this sort of, maybe it's a pink brownish type of color, will start the clock, or will start the timer to run. So let's look at the next one. Basically here you can see if the input is coming from T0, that means you will have sort of a direct input here. Or this is actually the, sorry, it's not a direct input. This is where we get the input from the external world, the counter, and otherwise I will get my input from the crystal, the clock pulse. And as we've seen now in the B register, here I can select which prescaler I want. I can either select no clock, or if I want a prescaler, no prescaler, I will put in 001, etc. So this is just a simplified block diagram of what will happen. Then normally we would make use of this normal mode here in this course. If maybe I will also show you how to do this clear timer on compare. So there could be a compare function, but for this specific course we are not really going to make use of the rest. Definitely we will make use of the normal mode, and maybe we will make use of this compare mode. But as you can see, to have the timer mode set, I have to make use of the 3 bits, 2 sitting in register A, the control register, and 1 sitting in register B, control register. So these 3 bits, the green ones that you see here, actually work together, and we will normally put this in normal mode, and yeah, as I've said, we could be using that one also. And that will be the only 2 that we will be using at this stage. Now let's look at this example, how to write a program that waits 14 machine cycles, and we're going to do that in normal mode. So from the 8051 that we've done previously, I can say that if you want something to run for 14 machine cycles, we are used to basically load the counter, or the timer values, timer registers with a value of 256 minus 14. And here we are actually going to do exactly the same. So what you see here, because remember timer 0 is an 8-bit timer, we're going to load this with 256 minus 14. So we're going to load it with a decimal value of 242. Now we are used to actually write hex F2, and I just want to show you this is another way to use the dollar symbol here before F2. It accepts both dollar and also 0x. So this is the value that should be loaded in your timer counter register. I think that is called, let me just have a look, the TCNT0 register. Yes, that is the register that it will be loaded into. Then, well, as it says here, this is where you're going to load that hex F2 value inside your counter register, meaning if it receives 1 pulse here, the first pulse that it receives, it will basically count up to F3, with the next pulse to F4, etc. So we have got the A and the B control registers, and we know by now that this 3 bottom bits in the B register basically determines your prescaler, and those green bits, those 3 that work together in the A control register and the B control register, basically determines the mode. So if we go further, in this specific case, we basically know then if it's the prescaler, we don't want any prescaler in this specific program, but we want the counter to start. So we will load the 001 into this specific 3 bits, and we will just look at the green area just now in the next section. So that is what I've said already, and we want to use the normal mode. which is this one here, which means that should be a 0, that should be a 0, and that should be a 0. So looking at what control register A should be and control register B should be, let me just carry on there. You will see that the A register will then be 0 here, 0 here, and the B register will be 0, 0, 0, 1, which is, it should be loaded with a value of 0, 1. A register should be loaded with 0, 0. And by doing that, I start the clock pulse, but there's no prescaler, and it's in normal mode. And it starts counting from F2. This is then the end of the second video. And the next videos I will show you how to do calculations, but also how to implement some timer problems.